Hey, welcome back. In this video, we're going to be solving an integral using the integration by parts method. This is going to be a pretty easy introductory example. So just so you're aware, or so you remember, the integration by parts formula is right here. It's the integral of u dv is equal to uv minus the integral of v du. Now when you first look at that, you're like, what the heck is this? I have no idea. But basically what we're going to do is we're going to define certain parts of our integrand as u and dv, and then we're going to find the rest. So the way that we do that is that we just pick one side that's going to be easy to derive and one side that's going to be easy to integrate. In this case, it's kind of both. It doesn't matter, but we'll just pick one for example. We are going to call this u. This is the one that is going to be derived. And then we're going to call the rest of the whole integrand dv. Okay, so now we already have defined u and dv here, and actually the integral of u dv is exactly what we have here, the integral of u dv. So we already have 1/2 of this expression, and then we just need to derive u to get du, and we need to integrate dv to get v, and then we're going to have everything we need. So let's get started, and we're going to work through the problem, and you're going to see that this is actually pretty straightforward. So taking u as x, if we derive this with respect to x, we're going to have du dx is just equal to 1, and then we can rearrange, so we have du is equal to 1 dx, effectively just multiplying basically dx to both sides. Now for the other part here, dv, we can just write that down. We have dv is equal to e to the power of 2x dx. This is what we have just defined right here. What we want to do is we want to take the integral of dv. So the integral of dv is just going to be the integral of that stuff, e to the 2x dx. And the integral of dv is just going to be v. And the integral of this stuff, let's take a look at the integral table, which there is a link to this in the description below, but this is basically on the Engineer for Free website. And we're just going to look through here to see if we have the form that we were looking for. And we had the integral of e to the power of 2x dx. And so when we look in here, we see this format. The integral of e to the ax dx is equal to 1 over a e to the ax plus c. So in our case, we have e to the 2x dx, so this is going to apply to us. So let's bring that into our problem. So in general, that was the integral of e to the ax dx is equal to 1 over a e to the ax plus c. And now we can substitute in our value for a. So in our case, again, we just have 2. So we can just substitute all these instances of a for 2. So the integral is just 1 over 2 e to the 2x plus c. So let's just double check now that we have all of the parts that we need for the integration by parts formula. So we have u and dv already defined as x and e to the 2x dx. So we have u and dv already accounted for. We have another instance of u right there. We just found v here, so we've got v in there, and we found du, so we have du. So we actually have everything we need to fill out this formula. So let's do exactly that. We have the integral of u dv, which is the original problem. We have that's x e to the 2x dx, which is also equal to I. That's just exactly what we had right up in here. And then for the right-hand side of the integration by parts formula, we just need to start plugging and jugging. So we have u times v. So let's find u. U is x. We've got x, and then v is right here as 1/2 e to the 2x plus c. So this is going to be times 1/2 e to the 2x. In this case, you're going to find it's going to be a lot easier to just drop the arbitrary constant in your expressions. You don't have to. You might get in trouble for this in your class. You may not. It depends. I'm going to drop the arbitrary constant for now just because it makes the calculation easier, and I'm going to add it back in at the end. As long as you remember to add it back in at the end, you should be fine. So we have u times v, which is just right here, u times v. Now we need to subtract the integral of v times du. So minus the integral of v, and again we have v right here, 1/2 e to the 2x plus c, but I'm going to drop the plus c for now. And we're going to multiply this because it's multiplied to du, and du was 1 dx. So we can multiply that by 1 dx. Alright, let's just simplify this a little bit. So we'll just rearrange this one to look a little bit nicer. 1/2 x e to the 2x. Nothing really going on there, just rearranging. Minus, we can pull out this constant of 1/2 times the integral of e to the 2x dx. Now, what happens with integration by parts is you usually have to integrate something in here again, but it makes this integration much easier than the original integration. So here we only have to integrate e to the power of 2x, and actually we're going to use the same table entry for that, so we can just plug this in as well. So the first term here is not going to change. It's just going to be 1/2 x e to the 2x minus 1/2 times this whole integral, which in our case is going to be 1/2 e to the 2x plus c. Now we can put in the plus c if we want, it doesn't really matter. This 1/2 will get distributed to the plus c, but it's just still going to be an arbitrary constant. We don't know what it is, whether we multiply it by 1/2 or not. That's why I always just try to leave it out for as long as possible. But anyways, let's distribute this in a little bit. So we actually have, we can simplify, we have 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And I think we can simplify this a little bit just to make it a little nicer. We can pull out 1/4 actually. We're going to pull out 1/4 and an e to the 2x. And then this is going to be left with, when we pull it out of this first term here, if you pull out 1/4 from this, what would you have to multiply 1/4 by to get 1/2? And that would be 2. So we're going to be left with a 2 plus that x here minus 1, and that's all going to be plus c. And this is actually the solution to our problem. Maybe we should write down here that I is equal to all this, but this is basically the solution to the original problem, where we were asked to find out what is I. Well, how can we take the integral of this using the integration by parts formula? Well, we do all these steps, and we're left with this solution.